Sorry, the mic was not on. Now the mic is on. So what's different about this problem is we're rotating around y equals -2 instead around the x or y axis. And so this is going to be able to enable you to do your last assignment. But we want to check this guy out. So I'm going to start by drawing this region that I'm rotating, okay? And I'm going to go here. It says x plus 2y is equal to 6. Somebody tell me, what does that look like? Line, and has an x-intercept of 6 and a y-intercept of 3. Very good. Yep, what would you plug in to make 6, right? So 2 times 3 is 6, and 6 is 6. So we got this y-intercept of 3, 1, 2, 3, and x-intercept of 6. And there we've got it. Cool. And it says it's going to be bound by x equals 0. Well, what's x equals 0? Yeah, it's this guy right here, right? So we got this guy. And then what's y equals 1? Yeah, a horizontal line at 1. So it looks like I've got this region right here. That's what I'm rotating. And I'm rotating it around what? Y equals -2. So I'm going to rotate it around this. So as I rotate it around that, notice that how many units are there from the bottom of the area to the actual line of rotation? 3. So 1, 2, 3. So that's where I'm going to end up with my, the reflection of the next shape. So you got a lot of space there. Everybody see it? Here's the way that I like to organize my work with washers. When I draw the washer over on this side, I like to draw lines from where the shape was formed. So the original area up here, if this shape was formed from the area up above, right? So therefore, I'm gonna draw these dashed lines there, and there, and there. This middle part is created by an axis of rotation of y is equal to -2. What makes up this part right here? Y is equal to 1. And what makes up the top? This thing, right? So is the thickness of the washer, is it horizontal or vertical? It's horizontal, so it's dx for the thickness. That's little r. What's little r? How'd you get that? -2 to 1. Top minus bottom. So when you get confused, go back to top minus bottom or right minus left. Top minus bottom, you got 1 minus -2 is 3. Now, since this is x plus 2y equals 6, and see now it's dx, it must be a y equals in terms of x, correct? So we've got so we got, let's see, 2y equals 6 minus x divided by 2. We got y is equal to 3 minus 1/2 x. So now I need to come up with my larger radius, big R. So the distance from the very top to the axis of rotation is going to be 3 minus 1/2 x minus -2. We good? So minus -2 says it can be adding 2, correct? So I've got 5 minus 1/2 x. That's big R. So that means that the area or the volume of one of these washers is going to be big R squared, or 5 minus 1/2 x squared, minus little r squared, or 9, times dx, times pi. That's the volume of one of those washers. I want an infinite number. Slap on the integral. In red, I'm going to shade the original area. Do you look for x values or y values? Look for x values because it's dx. So where do I start? 0. We want to take a guess where I end? 4. So how do we know it's 4? Isn't that the intersection between y equals 1 and this guy? If you plug in 1 for y, you get x plus 2 is 6. So x is 4. That's the intersection. Excellent. We have the setup. Now let's evaluate. Piece of cake upside down. Pi times the integral 0 to 4 of. Got to multiply that out. 1/2 x quantity squared. That'll be 1/4 x squared. -5/2 x and -5/2 x is just -5x. Square of the 5 minus 9, what are you going to get? Yep, so you got 25 minus 9 is 16. Antiderivative of x squared. X cubed over 3. So instead of 1/4, it's going to be 1/12. Antiderivative of 5x is 5x squared over 2. Antiderivative of 16 is 16x. And I plug in 4. 4 cubed. 64 divided by 12. See, both are divisible by 4, right? So 16/3. And if you plug in 4 here, 4 squared is 16. Divided by 2 is 8. Times 5 is 40. And then 16 times 4 is 64. -40 and 64 make 24. So pi times 16 over 3 plus 24, or 72 over 3. I'm looking at 88 pi over 3. And that's that. So I'm going to end that